Topic: Submodules vs Subtrees. Submodules vs Subtrees. What does submodules vs subtrees mean? Submodules and subtrees are two ways to include one Git repository inside another. They are used when you want to reuse code, you depend on another project, you share common libraries, you manage multiple repos. Why? Keeps projects modular, avoids copy-pasting code, allows reuse of components. What is a Git submodule? Git submodule equals a Git repo inside another Git repo as a reference. It stores a link to another repository, a specific commit of that repo. It does not copy full history into main repo. Why? Keeps repos separate, tracks exact version, lightweight. In simple words, submodule equals repo inside repo. By link. How Git submodules work. Main repo stores path to subrepo, commit hash of subrepo. The actual code lives in another repository. Why? Parent repo depends on child repo. Versions are controlled. No duplication. 1. Adding a submodule. Process. Choose repo. Add a submodule. Commit change. Conceptually, main repo points to another repo. Why? Easy to add external dependency. Keeps history separate. 2. Cloning the repo with submodules. When cloning, main repo clones. Submodules are empty by default. You must initialize them. Why? Extra step required. Can confuse beginners. Needs manual update. 3. Updating submodules. To update submodule, go inside submodule, pull changes, commit new pointer in main repo. Why? Main repo controls version, prevents accidental upgrades. What is a Git subtree? Git subtree equals copying another repository into a folder of your repo, but keeping its history. The code becomes part of your repo. Why? No separate repo link. No special commands needed. Works like normal folder. In simple words, subtree equals repo inside repo. By copy plus history. How Git subtrees work. Subtree pulls another repo, merges it into a folder, keeps commit history. Why? No external dependency. No need for submodule setup. Easier cloning. 4. Adding a subtree. Process. Choose repo, choose folder, pull code into it. Conceptually, external repo becomes part of main repo. Why? Self-contained, simple for users, no special tooling. 5. Updating a subtree. To update subtree, pull new changes, merge into subtree folder. Why? Syncs external project, keeps history, one repo only. Submodules vs subtrees. Submodules. Separate repository. Uses pointer. Needs special commands. Harder for beginners. Lightweight. Subtrees. Merged into main repo. Full code included. Works like normal folder. Easier for users. Heavier. Why? Submodule equals reference. Subtree equals copy with history. When to use submodules. Use submodules when check mark you want strict separation. Check mark external project is independent. Check mark you want version locking. Check mark you control both repos. Check mark library changes separately. Why? Keeps repos clean. Strong dependency control. When to use subtrees. Use subtrees when check mark you want simple cloning. Check mark you want one repo only. Check mark you don't want setup steps. Check mark users are beginners. Check mark you want bundled code. Why? Easy for teens. No extra Git knowledge needed. Common beginner mistakes. Forgetting to init submodules. Editing submodule without committing pointer. Using submodules for tiny code. Not understanding subtree history. Mixing both without reason. Why? Code goes missing. Repo breaks. Confusing workflow. Real life example. Submodule equals linking to a book in another library. Subtree equals photocopying the book into your folder. Why? Link equals lightweight. Copy equals self-contained. In simple words, submodule equals repo inside repo. By link, subtree equals repo inside repo. By copy, submodules, smaller, more complex, separate repos. Subtrees, bigger, simpler, single repo. Use. Submodule means when dependency must stay separate. Subtree means when you want everything in one repo. Submodules vs subtrees equals control vs simplicity balance scale.